Okay, now we're in the 5th chapter of the 3rd unit, which is compound interest formula. So today we're going to become familiar with the derivation of the compound interest formula, and we're going to make computations using that compound interest formula. So let's go ahead and get started. The first example here says Jose opens a savings account with a principal of P dollars. Actually, we're going to deal with an actual value, so I want you to cross P out, and we're going to use $5,000 for our example. So it's $5,000 that pays 5% interest. It's compounded quarterly, which is 4 times per year. And what will his ending balance be after a year? Well, so far, all we've done is a formula using simple interest, which is our I equals PRT. And that's what we're going to do today so that we can figure this out. The downside of that, because it compounds quarterly, it means we're going to have to do this process 4 times. So let's identify our values here. The principal is $5,000. The rate as a decimal is 5%. And because it's quarterly, when you think of a quarter, in terms of a year, it's 0.25% of a year. So, looking at our values, interest equals PRT. We've got P is 5,000. Let me rewrite that real quick. So, P is 5,000 times the rate, which is 0.05, times the time, which is 0.25. So I've gone ahead and pulled up my calculator. So let's go ahead and multiply that, and we can see how we're getting this. It's 5,000 times 0.05 times my 0.25. So the amount of interest that's going to be earned after that first quarter there is going to be $62.50. And that's quarter 1. Now, in order to find the principal for quarter 2, we're going to take quarter 1's interest. We're going to start with the regular principal, and we're going to add that first quarter interest to it. So now we have $5,062.50. So that's our second, or our new principal value in finding the second quarter. The interest rate stayed the same, and so did the time period. So going back to our calculator, we're going to clear this value out. Now we've got 5062.5 times 0.05 times the time, which is the 0.25. And our new interest is $63.28. So it would make sense that it's just a little bit more than before because we posted the first quarter's interest to the account, increasing the principal. Therefore, the interest the second quarter is also going to be larger. So we're going to add that $63.28, and now we have a principal balance of $5,125.78. So coming over here, $51.25.78 is my new principal for the third quarter. Interest rate stays the same at 0.05, and the time stays the same at 0.25. Going back to our calculator, we're now going to put in our 5,125.78, and we're going to multiply that by 0.05 times the 0.25, and we get $64, and actually it looks like I made a quick error, so let's see what I did. We've got 5,125.78 times 0.05 times 0.25, and that looks a little better. So we have $64.07. So 64.07 is my third quarter. I'm going to add that 64.07 over here, and I get 51.89.85. So that's going to be my last principal for my fourth quarter. Again, the interest rate and the time stay the same. So let's go through this process one more time. We've got 5189.85 times 0.05, the interest rate, times the time, which is 0.25, and we find that our last bit of interest is 64.87 for quarter 4. Now the question says, what is the ending balance after 1 year? So what we're going to do is go ahead and we are going to add all of these values together, and we find that in 1 year, $254.72 was earned in interest. We're going to add that to that original principal balance, which was $5,000, and so the total in the account was $52.54.72 after 1 year. Please press pause and solve this you do. When you're ready, press play and we'll get started. Okay, let's see how you did. So we've got a principal balance here of $800. We have a rate of 0.0387, and we have time of 0.25. So going through that process, it's going to be 800 times 0.0387 times 0.25. And I end up with $7.74. Now I'm not going to go through and do this on the calculator because we just did it, and hopefully these are all the values you're getting. But you can follow along, and if you did not get this amount, then you're going to go ahead and go back and see what happened and why you got a different amount. So there's quarter 2, we got 781. We're going to add that in, and so now our new principal is 815.55 times the 0.0387 times 0.25. Third quarter's interest is $7.89. So again, you notice it's going up just a little bit each quarter. So I'm going to add that to my existing principal, multiply it by the rate and by the time, and my final bit of interest there is $7.97. So when I add that into the 823.44, I get $831.41. That is the ending balance after 1 year. So how'd you do? All right, example 2, it says if you deposit P dollars for 1 year at 5% compounded daily, express the ending daily balance. So we're going to go ahead and use our 5,000 again. And looking at this, it's compounded daily. So let's think about this. We just did it compounded quarterly, which means that you need to do it 4 times to get that value. How many times are we going to have to do it if it's compounded daily? And if you answered 365, you would be correct. Now, I don't know about you. I don't want to do this 365 times. So that's where we come into our compound interest formula. And I'm going to kind of take you back a couple of screens here that we did not go over yet. The compound interest formula is this. It's B equals P times 1 plus the R over N all to the NT. So you can look up above, and I've already written down here that B, it means your ending balance. That is the principal plus the interest. That's different than the simple interest formula because it just gave you interest and you had to add it back in. But here it already does that for you. P is still the principal or original balance just as it used to be. The rate is still expressed as a decimal. Now this N, that's a new thing for us. And N is the number of times it's compounded annually. So if something is compounded 4 times, N would equal 4. In this case, it's compounded 365 times, so 365 would be your N. And then finally, T is still time in years. So let's go ahead and we're going to use that compound interest formula. We're going to plug it into our calculator and we're going to see how we do. But first, let's identify our values. The principal is 5,000. We said that the rate is 5%. we already determined that n, or the number of times it compounds, is 365, and the time it says after 1 year. So let's take a look at this with the calculator. Let's plug it in first. So I get B equals, and remember the formula was B equals P times 1 plus R over N all to the NT. So plugging that in, we've got 5,000, 1 plus 0.05 divided by 365, all to the 365 times 1. So let's plug that into our calculator. We'll clear that out. The first thing we're going to do is we've got to follow Pemdas when we're doing this. And remember, with Pemdas, we know that our parentheses come first. So we're going to take the fraction part of it and do 0.05 divided by 365 plus 1, and that takes care of the parentheses. The next thing is our exponent. So when we do our exponent, we've got to the x to the y power, so it's going to be to the 365th power. And then the last thing we're going to do is multiply it by 5,000, because multiplication comes next. And when we do that, we end up with a value of 5,200, I didn't catch it all, $56.34. A lot easier than doing this 365 times. So what I want to do real quick is let's go back for just a second to our first example. And let's take a look. What if we just punch this into our formula, knowing now what it is? So B equals 5,000 times 1 plus 0.05 divided by 4, because it compounds 4 times. So these are going to change. N is 4, and we're now talking 1 year for time, and then it's to the 4 times 1. If we plug that into our calculator, we've got 5. Actually, let's do our interest rate first. So we've got 0.05 divided by 4 plus 1. And we've got that to the 4th power, and then multiply that by the 5,000. And you can see here that the amounts equal. Here I've got 52, 54, 72. And then in the calculator, 52, 54, 72. So you can see, again, a much easier method than what we were doing. All right, it's your turn to practice. Please press pause, solve this equation. When you're ready, press play, and we'll go through it together. Okay, let's see how you did. So first off, we've got to take care of our values. We've got P, BP, R, N, and T. So again, I want you to always be writing that out so you can identify the values, and it'll be a lot easier when you're working through it. So P is 1,200, R is 3%. It compounds monthly. Well, there's 12 months in a year, and we're talking for 1 year. Plugging it into my formula, I've got B equals 1,200 times 1 plus 0.03 divided by 12, all to the 12 times 1. So let's plug that into the formula. Let's plug it into the calculator. So we've got 1,200. Now we could do this all at once. So we could do 1,200, and let me clear this out. Actually, let's go ahead and do it the way we've been doing it. So 0.03 divided by 12 plus 1, all to the 12th power, times the 1,200, and we find the ending balance is $1236.50.